This demonstration will show how the BALAS adapter produced by the Arrowhead FPVN project can produce machine-interpretable engineering and design data in a standardized format such as DXP process or PLM-RDL2. This is a diagram of the Arrowhead framework. The demonstration will be using Arrowhead Framework 5.0, where the systems have different names than this diagram implies. Instead of authorization, we actually have consumer authorization, and the orchestrator is replaced by dynamic service orchestration. We have a service provider providing the services for converting files, which publishes its services to the service registry. We have a consumer script that consumes the services. Normally, we would request the services from the orchestrator, but in this demo, we're using only the service registry. So we're actually looking up services from the service registry, bypassing the orchestrator. This is a diagram describing the structure of the BALAS adapter. Here we have the consumer that connects to the provider system to the REST API, and the provider then connects to the BALAS adapter backend itself. And the backend then uses one of 4 converter components. And that converter component then connects to a graph database to perform mappings. The converted file is stored on the backend storage, and then it can be downloaded from there through the provider. Our provider uses this config file to read info on the adapter and info on its own system to be registered in the Arrowhead framework. It also reads the info on the services, such as the conversion services. Here we have adapter DXP process service, which contains 2 service operations, JSON to DXP process and DXP process to JSON. So it registers this service interface with this service name to the Arrowhead framework. Let's start the provider. So the provider uses its bearer token to identify itself to the Arrowhead framework. It registers itself as a system, and then it registers services that it provides. Now let's run the consumer script. We use the conversion JSON to DXP process, and we use the input file example model2.json. The script first registers the consumer system, and then it fetches the relevant service, adapter DXP process service, and then it consumes the JSON to DXP process conversion operation with this input file. And then it fetches the file system service and uses the download operation on that service, and then saves the file that was downloaded. Then it revokes the system after the service consumption. We can find the downloaded file here. It's an XML file. We can open it in the browser. Let's also open the input file. So now we have streams. A stream is mapped into a process connection such as S101 here, and the components are mapped into the material state of this stream. As for the unit processes, a unit process is mapped to a process step, and the parameters are mapped to BALAS parameters. Now let's run the same consumer script using the text process to JSON conversion with an input file that is a text process XML. Again, we fetch the service instance, and then we consume the operation to convert the file, and then we download the resulting converted file. And now we have the input text process XML on the left here. And the result of the conversion to BALAS JSON on the right. Now we convert from BALAS JSON to PLM RDL2 format by using the consumer script with the JSON to PLM RDL2 conversion argument and the example model2.json as the input file. We fetch the adapter PLM RDL2 service, and then we consume the conversion operation with the input file. And then we download the file from the file system service and save it. Now we have the input JSON on the left and the output turtle file on the right. For streams, let's check out S101. So a stream gets its own predicate list with info about its components and parameters. Each unit process also gets its own predicate list with its type and members such as parameters and ports. Now let's convert from PLM RDL2 format to JSON with the consumer script using this example model2 turtle file as the input file. We fetch the conversion service. We use the conversion operation with the input file, and then we fetch the file system service and download the file and save it. And now we have the input turtle file on the left, and the output BALAS JSON file on the right. Now, when we shut down the provider, it revokes all the services it has registered, and it revokes also its own system on the Arrowhead framework.